Hello friends, so today is our problem solving day 7 from GFG. So look at the problem. uh, yeah, so here is our problem. Given a list of intervals of any intervals, the ith element SEP denotes the starting point S, ending point E and the point P, and by choosing the ith interval find the maximum profit one can achieve by choosing a subset of non-overlapping interval, and this is the overlapping condition. Okay, so if two intervals are given like this, okay, then the non-overlapping condition is this one. Okay. So let's understand the question first. Okay, understand the question first. So just take this screenshot. uh, okay, right, so take this screenshot. So what they are saying is that so uh, so what does the question is saying? So we have given a 2D array. Okay, so this is a 2D array, this is a 2D array. Okay, and for each element of this 2D array, each element, so this is an element of the 2D array, this is another element, this is another element. So take this element 1 2 4, 1 2 4. So what does it represent? It actually represents that uh, uh, yeah, so between 1 and 2, between the time interval 1 and 2. Okay, so it's is it given that it's a time interval or not something? Yeah, so no, it's not given. So what they are given, so let's take these are time intervals. So this is a starting time and this is my ending time, and suppose this is actually what this is actually is actually job scheduling problem. Okay, so this is actually job scheduling problem in another way. So what we are asked is that this is the starting time. So 1 is our starting time, 2 is our ending time, and between this time interval 1 to 2, so between this time interval, just drawing a real number line, between this time interval 1 to 2, we have a profit of 4. We have a profit of 4. So I want you to understand the question first. Okay. So between time interval 1 to 2, suppose there is a person who do his job between this time and he will get money. So his profit is 4 for doing a job between this interval. Okay. Similarly for this element 157. So what it is telling, this is my starting time, this is my ending time, this is my profit. So this is my starting time 1, this is my ending time 5, and I am doing a job for 1 to 5 and I will get a profit of 7, right? Okay, so similarly for 2 4 4, this is my starting time, this is my ending time, this is my profit. So for 2 to 4, if I do a job for 2 to 4, so my profit is 4. This is given. Okay. So I hope you understand the question. We have given a 2D array. So 2D array is like matrix, so I can represent this like a matrix 1 to 4 1 5 7. There is no use of matrix here in this question, I am just writing. So the first row or the first element, let's keep it as an element. So this is my array. So the first element is representing 3 things, right? 3 things it is representing. First thing is my starting time, second thing is my ending time, and the profit for doing a job, suppose from the starting time and ending time. Okay, So this is the question is given, the information given to us, right? So what we have to do is, let's erase these parts. Uh, yeah. Okay. So what we have to do is, we have given these intervals. What we have to do is we have to find the maximum profit. The maximum profit we can gain. Maximum profit we can gain by, just by, non from non-overlapping intervals. Okay. So what does it that mean? That, suppose consider this case. So 1 to 2. Here is 1. Here is 2. Here is my 3, 4, 5, 6, 7. Right. So for So for 1 to 2, I am having a profit of 4. From 1 to 5, I am having a profit of 7. Right. From 2 to 4, from 2 to 4, I am having a profit of 4. So I have to find the maximum profit I can gain by just, including the non-overlapping intervals. So I have to just include all the non-overlapping intervals such that I can gain a maximum, profit. Okay. So what does that mean? Look here. So suppose this is an interval 1 to 2 and 2 to 3. 1 to 2 and 2 to 3. So I will say these are non-overlapping intervals. Okay, so someone is ending at 2 and someone is starting at 2, some interval. So it will be a non-overlapping interval. So the given condition in the question also is that if two intervals are like S1 E1, starting time and ending time for this interval, interval 1 starting time and ending time are this, and for interval 2 starting time and ending time are this. Okay. So if E1 is less equal to S2 and my S1 is less than S2, this is, not so usable. This is the most important thing. E1 must be less equal to S2. That means the first interval, this first interval. Okay, so I'm just, counting from left. So the left first interval, it is ending at 2, and the after interval is starting at 2. So these are non-overlapping interval. Why? Because it never can overlap each other, because it is starting but the other is ending, so it can never overlap each other, right? So this interval and this interval are non-overlapping interval. Why? Because it is starting from 1 ending at 2, and this one is starting at 2 ending at 4, and it gives me a profit of 4. So these are two overlapping intervals, give it a total profit of 8, right? 4 plus 4. So I have to include all the overlapping intervals so that I can, generate a maximum profit. So my maximum profit is 8. Okay, so the answer is actually 8 in my given question. Let's see. Okay, so here. So our answer is 8 for 1 to 4, 1 to 4, 2 4 4. Right? So as we see, this one is 1 to 4 and this one is 2 4 4. Okay. So let's take another example, then we will understand this. Let's take, 5 intervals. Okay. Suppose, 1 2 4, and then, 2 3 5, then 1 to 5, then 2 to 7, then 3 to 7. Yeah, 3 to 7. Suppose this is 2. So what does it mean? I have a 2D array. I have a 2D array like this, which is given like this. So what does that mean? So let's see the answer by our diagram solution. So this is I called a diagram solution or diagrammatic solution. Okay, so we don't have to compute anything. We just see and say the answer. So here is my 1, here is my 2, 3, 4, 5, 6, 7. Okay, so this is enough. So from 1 to 2, I am having a profit of 4. From 2 to 3, so where is it? 3. 2 to 3, I am having a profit of 5. From 1 to 5, from 1 to 5, I am having a profit of 7. From 2 to 7, from 2 to 7, I am having a profit of 8. And from 3 to 7, from 3 to 7, I am having a profit of 2. Okay, so there are many intervals. This is 1 to 2, then 2 to 3, then 1 to 5, then 2 to 7, and 3 to 7. Okay, so what are the non-overlapping intervals? So, so 1 to 4 and 2 to 3 are two intervals, right? So this one and this one are two non-overlapping intervals. And also including this one. So these three, this one, this one, this one, both of the three are non-overlapping to each other. They are not overlapping each other, right? So if we consider this one, I will get a profit of 4 plus 5 plus 2, 11. Okay. Is there any other possibility? Yeah. So if I consider this one and this one, this one and this one, they are two overlapping intervals. If I consider this one and this one, there can't be any other overlapping intervals in this case, because they actually covered all the total interval 1 to 7, right? So if I add these two, these are 4 plus 8 equal to 12, right? And there may be another case. What are the cases? So see, here is 2 to 3 and 3 to 7, right? 2 to 3 and 3 to 7. But in that case, we can include 1 to 2 also. So actually, we will not consider 5 plus 2, because we can include 4 in that case also. So I have to count the maximum. Okay. So I am counting actually the maximum. So that's why I am not taking this 5 plus 2 cases as a separate case, and then 2 as a separate case, and all these things. I am not doing that here. I hope you understood. All right. I think there is not more than these cases. No. These are all the cases. So then what are the maximum? Maximum is 12, right? So from which we can get this one and this one, right? So this is my answer. My answer is actually 12. I have to print 12 or return 12. So there are many non-overlapping intervals. So there may be a collection C1 which contains some non-overlapping intervals, and their total profit is suppose X. And there may be suppose another collection of non-overlapping intervals which sum up to suppose Y. Then I have to count. I have to give you the maximum, right? So if X greater than Y, so my answer is X, otherwise Y. Okay, So there are many intervals, non-overlapping. There are collection, right? So remember my words, collection of non-overlapping intervals. There may be many collection of non-overlapping intervals. So we have to give the maximum profit. So which collection is giving me the maximum profit? I have to give the dot that count, right? So how we will count? We can just doing this, right? So we are just observing. It will take very long time. So what we will do is we will use DP here. This is actually the job scheduling problem. So dynamic programming problem. This okay. So let's see how we can do it. So we get our answer as 12, right? You see now. So our answer is 12. So let's see our approach. Yeah. So uh, I am making a storage, right? So I hope you know that the rules of DP. You have to see DP first, then you have to solve, look into this problem. So DP actually bases on three things. Okay, tabulation, storage, uh, storage, storage. Uh, what can I say? Defining storage, and direction of the problem. So what does that mean? That uh, tabulation means I have to first create a table or uh, something array or something. Tabulation means I have to create a space or storage. Okay, so creating a storage, creating a storage. All right. So what is the this thing defining storage? This means actually. So in this array, suppose this is an array. So there are many elements. So what does the element here means? I have to assign the meaning to a storage. Okay, so assign, actually it is assigning meaning to a storage. So what does that element here is actually representing? Okay, so you will understand while we will solve the problem. The direction is whether I have to solve the problem from here to here or here to here. It may be the case where we have to do a 2D array, then I am solving a problem. It may be the case, but in this case I am just having 1D array. So these are three things. Okay, so, all right. Mm-hmm. So yeah, so let's so what I have to do before just starting these calculations, I have to sort this. I have to sort the array. All right, I have to sort the array first, 2D array, on the basis of their ending points, right? They are ending points. So what will be then happen is that all the ending points will be like this, one after another. Not the first one, suppose the first one suppose is 2. There may be later an interval which is suppose ending at 1. Okay, so I then can calculate this, cannot calculate this in an easy way. So to calculate in an easy way and solving by DP, I have to sort them in the basis of this ending interval, right? So the what will actually happen after that, I want you to understand this, is that suppose here is 1 2 3 4 5 6 7 8 9 10. All right. So suppose we have given the elements like 2 3 4, then 1 2 6, then 4 5 9, then 1 4 6. So you are seeing that first the 2 3 element is given, then 1 2 is given, then 4 5, then 1 4. So I want them to actually uh, set in such a way that the first one is the first one is the actually first interval, the second one is the second interval. You can think in a real number line. Okay, so the first one is the first interval in my real number line. The second one, second interval is my actually second interval in my real number line. The third element is actually the third interval in my real number line. The fourth element is actually the fourth interval in the real number line. So when I represent this in my real number line, it should be actually in their own positions. So this is actually standing for second position. So after sorting, it will be at second position. So when I'm plotting this one, when I'm plotting this array 2 3 1 2 6, right, I will get this interval in this position second. So after sorting, it will be at second position. So I am actually then I am actually give I am actually gaining the second interval at second position itself. So I do not have to think about the positions of the intervals. Okay, so that is why we are sorting. I hope you understood. You can think this and you will get it. Just I have to sort the intervals on the basis of last ending point, so that the ith interval is actually in the ith position. So maybe there is an interval which is actually in the real number is in ith position, but in my array it may be on some j position. Okay, so I am just sorting this so that it can actually set in their actual manners. So what we will do then? We will do sort. Suppose I am sorting this on the basis of their last position, last ending point. Okay, so I hope this is already sorted, right? 2 3 on the basis of their positions. 2, then 3, then 5, 7, 7. All right. So what I mean to say you that suppose there are three intervals like 1 to 2, then 4, then suppose here is first 2 to 3, 5, 1 to 2, 4, then 6 to 9, 10, then 3 to 7, 11. So are you seeing that 2 to 3, 1 2 3 4 5, oh, there is 6 7 8 9 10. So 2 to 3 is this one and 1 2 is my this one. So it's actually coming in second position, this one is in first position. So after sorting, it will be like 1 2 4 2 3 5. So actually my first interval in actual, when I if I plot this in a line, this one will be in the first position itself, this one will be in the second position. Like this one is in 6 9, is in the third position, and my 3 to 7 is in the 3 to 7, it is in the last position. So it should be in, so it should be before 6 9 10, right? Because actually it is before, this interval is actually before 6 9 10. So that is what I am saying. So I hope you understand now. Yeah. What I have to do, I have to assign meaning. Before that I am just writing. So this is 1 to 4, this is a time interval for 1 2, this is for 2 3, this is for 1 to 5, this is for 2 to 7, and this is for 3 to 7. Okay, and I'm getting a profit of 4 here, 5 here, 7 here, 8 here, and 2 here. All right. Yeah, so this is my array. Let's just this be dp. Okay, so I want you to understand one thing, that what does the storage means, what does the element here here the element represents, what does it represent? Okay, so I want you to understand it very carefully. So the element here represent the maximum profit, the maximum profit we can gain by solving up to this. I am solving the problem up to this, including this interval. Okay, including this interval. So this element here is actually represent the maximum profit we can gain by including this interval up to this. Okay, suppose here, what does the element here represent? The maximum possible profit by including this interval and up to this. So up to this means what? So my answer is asking me to consider only non-overlapping, right? So the non-overlapping intervals, I am saying once again, the non-overlapping intervals including this one. Suppose there is a collection C1 where there are these intervals. One interval is this, because this case, this element is actually representing that case where this interval is included. So in that collection, okay, so in that collection, the previous one or more of the intervals can be non-overlapping corresponding to this, right? See, there may be many intervals, suppose this one, and this one, or maybe someone. Okay, so they may be, because see, this is 3 7, right? So 1 2 is non-overlapping, 2 3 7, 2 3 is non-overlapping, 2 3 7. So what it actually contain is the maximum profit we can gain by including this interval. It must include this interval and the non-overlapping intervals corresponding to this, right? So those are this one, and not this one, neither this one. So for here the answer should be 4 plus 5 plus 2, 11, right? Here should be the answer should be 11. Including this interval, the solution up to, I mean, including this interval, the maximum profit we can gain including this interval. Okay, so the question is asking for the solutions where all the intervals are non-overlapping. So I am saying once again, then you will understand when you are solving, you will actually understand it very clearly. So suppose what I am saying is that here the number actually represents the maximum profit that we can gain by including this one and 5 and the corresponding non-overlapping intervals up to this. Yeah, that's correct, up to this corresponding non-overlapping intervals. In that case it is neither this one nor this one. So for this is the only non-overlapping intervals up to this, right? So here the solution should be only 7. So let's now solve the problem actually, then you will understand more clearly. Right. So what we will do, first we will just push the first element. So for first element we will just push it. Now for second we will start solving actually. So see what I have told you, if there is 2 interval, see these are sorted, right? So they are actually in their actual positions. Say I plot them in real number line or something else. So suppose one interval is this one, and after that there is interval S2 E2. So to be a non-overlapping interval, E1 should be less equal to S2, and S1 should be less than S2. Okay. E1 should be less than S2, S1 should be less than S2. So this one is important. So see, 2 is less equal to 2. This is my S1 E1, this is my S2 E2. So 2 is less equal to 2, and obviously 1 is less than 2, S1 less than S2. So these two are actually non-overlapping intervals. So for non-overlapping intervals, we have to calculate maximum. So it will be the sum of these profits, right? So if I take these two intervals as they are both non-overlapping to each other, so we will take both profits and we will get actually the maximum. So for this element, the answer is 5 plus 4, 9. 5 plus 4, see this element, not here, see here. Okay. 5 plus 4 is 9. You will understand what I am saying. So, so now so what it represents, the maximum profit we can gain by including this interval and up to this. So the intervals that are non-overlapping to this, up to this, and creating a maximum profit will be here, which is 9 in our case. If you understood, we will understood laterly. So here check, we will check from first. Okay, so for this case we will check from first, for this case we will check from first. Okay, so we will check from first and go like this. Okay, so go like this until we reach the last before the our this 7. Okay. Okay, so in this case start here. I have to check all the left cases, right? So for this one I have to include this interval, so I am checking all the left cases where this interval is non-overlapping to this or not. Okay, so that's why I am starting for here and checking if this is a non-overlapping or not, this is a non-overlapping or not, right? So if I get non-overlapping, I will add it and put it. So I have understood, because I have to include this one, I will add this surely, but I have to check if there is corresponding non-overlapping interval correspond to this one, right? So 1 2 and 1 5, as 2 is not less equal to 1, so they are not non-overlapping, they are actually overlapping, right? So let's see this one. Let's see this one. 2 3 and 1 5. So 2 is 3 is not less equal to 1. So these two are also not non-overlapping, they are overlapping, right? So the answer here, by including this interval with corresponding non-intervals before it, I can gain a maximum profit of 7 only, because there are no non-overlapping intervals before it, right? So our answer is 7 here. Now check here. Okay, check here. So I'm checking for this one. So I'm checking for this one and this one. Okay. So 1 2 and 2 7. So 2 is this 2. This is my S1 E1. This is my S2 E2. So 2 is obviously less equal to 2, and 1 is less than 2, right? So these are non-overlapping. So I will so what I will do, I will create a maximum variable and put this 4 here. I will later add this 8, not now. I will actually, what I am doing is I am searching for the maximum possible profit giving interval, maximum possible profit I can gain from which interval. So that interval I have to find from all these left ones, right? which are non-overlapping to what? This interval, which are non-overlapping to this one. So I will create a max and put it here 4. Then I am checking for this one. Is 2, 3 and 2, 7 non-overlap? No, 3 is not less equal to 2. And I will check this one and this one. 5 is not less equal to 2. And 1 is obviously not less than. Okay, so this is S1 E1, this is S2 E2, right? So 5 is not less equal to 2, but 1 is less than 2. So I have to actually satisfy both the conditions. So here only one condition is satisfied, this one. This one is not satisfied. So these are not non-overlapping, they are overlapping, right? So the answer here will be maximum plus this one, which is 12. Okay, I am going to do this once again, do all this array elements filling once again, don't worry. Then for this one I have to fill this one, so I am starting from here. So 1, 2 and 3, 7. So 2 is not less equal to 3, and 1, but 1 is less than 3, but this condition is failed. So these are not non-overlapping. Let's check this condition. 2, 3, 3, 7. So 3 is less equal to 3 and 2 is less than 3. So they are non-overlapping. So we will create our max as 9 here. When I will do the programming part, you will understand the max part. Now just suppose that there is a max which is containing initially 9. I will just get my maximum possible profit from the left sides. Then at the last moment I will add 2 to the max in this case. Okay, so I'm done. Maximum equal to 9, put it here. Now check this case, this one and this one. So I am checking this one, 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 right? So 5 is not less equal to 3, so our case is stopped here. I don't have to check it further because one condition already failed. Yeah, and 1 less than 3 here, right? So it's a failed condition, so they are overlapping. Now check this one, 2, 7, 3, 7. So 7 is not less equal to 3, and but 2 is less than 3. So these are overlapping also. So the maximum possible for in this case will be only 2 plus 9. So max is not updated because there is no other non-overlapping intervals. So 9 plus 2, 11 will be my answer, right? So what are the answers we got? So these are the answers, right? 4, 9, 7, 12, 11. So I will return the maximum of it, which is 12. So 12 will be my answer. So we saw that our answer actually was 12 when we do it diagrammatically, right? So 12 is my answer. So I will fill the array and find the maximum element, that will be my answer. So including this one, I can get the maximum profit of non-overlapping intervals. Okay, so I want you to understand this once again. So initially I put 4 as it is, right? I am starting solving from here. So this is my S1 E1, this is my S2 E2, right? So I will check these conditions. E1 less equal to S2, right? And 1 is less than 2, so S1 less than S2 is also satisfied, right? So yeah, so this is a non-overlapping interval. I will add 5 with this, so 9. So next I will solve this one. Solve this one. So this is my S1 E1, this is my S2 E2. So E1 is 2, S2 is 1. So 2 less equal to 1, nope. 1 less than 1, nope. This is not non-overlapping. Okay, this is not non-overlapping. Check this one. This is my S1 E1. Is E1 less equal to S2? 3 is not less equal to 1. not satisfied. S1 less than S2, no, this is not non-overlapping also. So here the case is only 7, because including this I got only this interval giving a maximum profit, which is 7. Now let's solve this one. So this is my S2E2, this is my S1E1. So 2 is less equal to 2, right? This condition satisfied. 1 is less than 2, condition satisfied. So these two are non-overlapping, right? So I will create a max and put 4 to here. It was initially 0, suppose. So when I get a non-overlapping here in the left side corresponding to the element I am solving right now, I will put that element here. It was 0 initially, suppose I updated it to 4. Now check this one. Check this one. This is my S1 E1. Is E1 less equal to S2? 3 is not less equal to 2, right? This is not. And 2 is not less than 2. So this is not a non-overlapping case. Here is my S1 E1. So 5 is not equal to, not less equal to 2, right? And 1 is less than 2 is right. This condition is satisfied here, but this condition is not satisfied. Both the conditions should satisfy, right? So this is also not one non-overlapping. So in this case, our answer is, our max was 4, and I will add this element to it, max. So it is 12. So now we will solve this one. We will solve this one. So here, this is my S2E2, this is my S1E1. So 2 is less equal to 3, right? And 1 is less than 3. So these two are non-overlapping, right? So my max is 4. My max was initially 0 for this case. Now it got updated to 4. For each case, max was initially 0. When I get an element non-overlapping type, I will update that. Okay. Now come to this point. S1E1 is this now. So 3 is less equal to 3, right? 2 is less than 3, right? So this is a non-overlapping, right? So maximum between this one and this one is 9. So I update this to 9. Now this is my S1E1. So 5 is not less equal to 3, right? But 1 is less than 3. But this condition is not satisfied. Both has to be satisfied. So this is a non-overlapping, not non-overlapping. This is my S1E1. 7 is not less equal to 3. 2 is less than 3. This condition is satisfied, but this is not. Both to be satisfied, right? So this is also not non-overlapping. So I will add my max to this 2. This is 11. Alright. So yeah. So my max is 12 here in this array. The 12 is my answer, right? 12 is my answer. So now let's code. So what I will do, I will first sort this way. So I'll create a sort function. Sort only sort. Okay. I am passing the intervals and column 1. Okay, so column 1 will contain the last interval. So I am sorting basis of that. Don't think about that sort part. Let's think that this is solved. We got the sort method. Okay. So now what I am gonna do is creating a DP. DP of m. Now I put the initial value as which one? This part. That the second part is containing the profit, right? So I will put initially the profit value. So then start from So yeah, start from equal to 1 less than n a plus plus. So keep here a max which is initially 0, and then for int j equal to 0, j less than I, j plus plus, j plus plus, and then we will check the condition, this condition, okay. So my uh, uh, interval j s1 s2 is my jth things, right? And I is my s2 e2, right? S1 e1 my jth thing, and s2 e2 my ith thing. So intervals j is e1, right? So e is my second column, 1. So intervals ji should be less equal to intervals I 0, s2, right? So s2 is the first part, I 0, and s1 should be less than s2. So s1 should be less than s2, s2 0. Yeah. So I will compute the maximum. So if my dpj is greater than max, I will update my max to dpj, and later after that I will assign my dp as max plus my interval value, right? Interval size. So I am creating the left side max, and after creating max I will add it to the my interval value, right? So this value, this value, this value, I will compute the max here, I will add it to the this value. So this is my interval, that one, interval I 2, and I will create an original max. I have to compute the total maximum value of the dp array. This is my original max, which is initially intervals 0 2. Okay, so let us keep it the first value as my maximum. If I get the maximum value, if this dpi is greater than my original max value, then I will update it. Alright, and then I will just return original max. Now let's create the sort function. So public static void sort, which will take a 2D array and the column. So what I will do, I will use an interface. So I hope you know the interface part. If you don't know, check YouTube how to sort a 2D array. You will get it. I am sorting array using an interface called comparator. Okay, so comparator, like this, and public we have to override the interface function, actually override public int compare. I will get final. Don't bother about that, just check it on the YouTube. You will get it how to sort a 2D array. Just bother about that. Don't have to be bothered, right? So array 1 and array 2. So if so will return array 1 column minus array 2 column. Okay, and yeah, so I hope I am done. So I have to add this 0 to is equal to 0. All right. So 0 j less than I. Intervals j1 less equal to intervals I0. Intervals 0 less than I0. So max equal to t picture. Intervals I2. dpi greater than or max. So it's all right. Let's compile it. See if any error. Yeah, everything is okay. Let's submit it. Yeah, so we got it. Okay, so I want to dry run this thing once. Okay, so let's dry run this thing. Let's minimize our array. Okay, so now let's dry run. So initially I put my first element as the 0th. So it was here like what was here, mm, 1 2 4 and 2 3 5, right? So first we sort this, it is already sorted. Then we will initialize the first element as our this one. Okay. So 4. So this is my first element. So 0 is represent the first element, and that second column. So 0th column, first column, second column. So 4. So 0th elements, second column, which is this one. So 4. So initialize with 4, and our original max is 4. Original max is 4. Int max equal to 0 goes into loop. So int max equal to 0. So I is here, we start from here. So and j starts from 0. So the interval condition is satisfied here. So my dpj, so dpj is 4. Is 4 greater than 4? 0. Yes, 4 is greater than 0. So I'll put my max as 4. Then j is becomes the last of i's left side. So the loop terminates, and we will assign dpi to what? Maximum, that is 4 plus interval I2. Interval I, this one, with second column element, which is 4. So 4 plus 5, 9. So I got my max. So this is my intervals. This is my ith intervals second column value. These are the second column values containing the profit values actually. So I will add 5 to 4, 9. Right? And loop again goes up. This is my I now. And my max is got 0 again. So the loop j goes from here to here. This is overlapping case. I will not consider it. This is also not overlapping case. So this condition fails. So this loop actually never got executed for this case. So my max was initially 0, it remains 0. So I will add 0 to my ith column, second ith row, ith element, second column value. So 0 plus 7. We got no non-overlapping intervals, right? So this loop doesn't get executed. So my max was initially 0. So it remains 0. And after the loop terminates by this condition, j less than I. So my dpi value is now max plus intervals ith second column value. So ith interval second column value is this one. Okay. So I will add 0 to 7 and my answer is 7. So I am solving now for this one, right? Okay. So max is 0. So these two are non-overlapping. So my max got updated to 4 here, right? My dp0 is greater than 0. It was initially 0, right? So I updated to 4. Again go to the loop. I will come here. This 2 is not non-overlapping. So this condition fails. Now my j is come here. This 2 is also not non-overlapping. This condition fails, right? And the loop terminates, and I will update my dpi as 4 plus 8, 12. Okay, so now my I pointer comes here, j pointer comes here. So max is my 0 now. So this is non-overlapping, right? So my max got updated to 4 and j is coming here. These two are also non-overlapping. So this value is, so I am comparing with dpj, right? So this is my dpj, right? dpj greater than my max. 9 is greater than max, so got updated to 9. Then the j comes here. There is not non-overlapping, not considering this case. J comes here, again not non-overlapping, not consider this case. And the loop terminates and assign the value of max value as 9 and my intervals value as this one. 9 plus 2 is 11. So while calculating these values, I am also calculating this one, right? So if my current value, so my original value was 4, right? So when I'm assigning this one, I will update it by 9. When I'm assigning this one, doesn't need to be updated. 7 is less than 9. When I'm assigning this one, it will update to 12. When I'm assigning this one, it remains same. So my original max value is my answer actually, right? I hope you understand. So after filling these values, each of these values, I was calculating original max. It was initially 4. And I compared these values. I filled the value 9, compare 9 to 4, updated to 9. I filled 7, compare 7 to 9, remain 9 as it is. I fill 12, compare 12 with 9, updated to 12. I compare 11, compare 11 to 12, 12 remains 12. So my answer is 12. Hope you understood. So let's see you in the next video.